Good morning, thank you for joining us for Webinar Wednesday for April this year. And today we are looking at designing for sound insulation in dwellings. My name's Katie and I'm Digital Services Specialist here at CABE, and I'll be acting as moderator this morning and helping you along if there's any questions or comments as we go. So in terms of questions, the way to interact with us it depends on whether you're on a desktop or an iPad or whatever device, but there will be a small sort of admin panel for you, either on the right-hand side of the screen or at the top. And within that, there's the opportunity to actually ask us questions. And you can do that by just typing in the questions as and when you feel the need. And then we can pick those up as we go along today. What we'll do is if we can answer any during the session, we will do, or we may leave some to the end. Again, if there's any questions on a particular subject or theme, we might leave those to the end. Alternatively, we may get back to you privately afterwards if it's a very specific example that you're referring to. As well, we're aware that a lot of people now watch our webinars on catch-up via YouTube. So if you are watching a recorded version of this webinar, again, you can still send questions through to us. Just drop us an email. You can find all our details via our website at cbld.com, where you can send us any questions, like I say, with regard to the content of today's webinar. So talking about content, your presenter is Kevin Blunden. He's Technical Director at CABE. And he will be talking you through today's presentation. So without further ado, I'll hand you over.
Thank you, Katie, and good morning. As Katie said, today we're going to look at sound insulation, particularly in relation to dwellings, and some of the issues we have, some of the ways in which we try and get a decent standard of insulation to be provided. When we're looking at designing for sound insulation, what we're really looking to do in terms of compliance with statutory legislation is protect ourselves from other attached buildings in terms of sound intrusion, or from other areas within the dwelling. So if we're in the lounge, we don't want to hear too much of what's happening in the bedroom, or vice versa. And we do that by looking at the construction of the walls, the floors, and the jointing mechanism. The building regulations don't necessarily address issues of sound insulation from the external environment, and quite often there's quite a bit of noise intrusion from the surroundings. We didn't pick up on it on Katie's introduction there, but the building she's in, immediately next door to that, is a police station, and she already advised me this morning they seem to be out there testing the sirens on several of the vehicles. Now, we fortunately didn't hear that during Katie's introduction, but that external noise pollution and insulation from the environment is something that in certain circumstances we have to consider in new construction as well. However, there is a balance. If you insulate properties too highly in terms of sound, people become isolated and feel disconnected from the community, and therefore that can have an adverse effect on their well-being and their environment. But for today, we're going to really focus on sound insulation within the building itself or from an attached building, as is the sort of standard that we're looking at in relation to building regulations. So when we're looking at sound, it's important to get some of the basics into our head in terms of how we're looking at it. And we basically measure the sound transmittance in decibels. But the first thing to appreciate with the decibel scale is it's not a linear scale, as you would with a tape measure or whatever. It is in fact a logarithmic scale. So an increase of 1 decibel is not a small incremental increase. It's actually a significant increase in the level of sound. So the smallest sound that we can hear, which is very nearly total silence, just the slightest sound above that, is round about 0 decibels. Okay, if we get to 10 decibels, that is actually 10 times more powerful, 10 times more intense than that 0 decibel sound, although that would still be very quiet. So 100 times more powerful is 20 decibels. So we're not simply going up in a linear scale. So when we get to 30 decibels, we are 1,000 times more powerful than that very near silence. And it's worth appreciating then that when we get to looking at sound levels, an increase of just a couple of decibels is going to have a significant effect on the actual sound level that we're talking about. So to give some examples of typical sort of levels that we encounter in our everyday life, I said near silence is the sort of benchmark, the 0. A whisper that's just heard by somebody immediately next to you would be about 15 decibels. And as we go up the scale, the rock concert, the jet engine is around about the 120 decibels. And those one-off, firework type sounds may be slightly more than that. And obviously, in addition to environmental comfort and ideal conditions, we do all have to also consider prolonged exposure to high sound levels, which can have a knock-on effect on the hearing in the long term. I'm sure many of us spent our youth with headphones on, listening to rock music, and as a result, our hearing perhaps nowadays isn't as good as it perhaps used to be. And long-term exposure can cause issues. But what we're trying to look at really is trying to reduce down the sound intensity from its source to the point where somebody who's not part of that activity in another part of the premises or in an adjacent premises no longer finds that to be a nuisance. So reducing by 50 decibels is actually reducing the sound intensity by 100,000 times. And that would normally take a typical normal conversation down to the level of a whisper. So in most buildings, we're looking for something similar to that. We don't want to be able to hear people talking in the property next door. If we can reduce it down to the point where it's a whisper, it's unlikely that it's going to cause us a particular problem. But some extremely loud noises will still be loud enough to cause us a nuisance. And if somebody next door, I'm not necessarily saying somebody next door is going to be repeatedly firing a gun, as is on this slide, but if somebody next door is repeatedly playing loud music, then in reality that will cause a nuisance because it will still transmit a reasonably high level of sound to the person on the other side of the party wall. And you probably saw a case recently to court where a neighbour was driving their neighbour mad because they'd had a disagreement by continually playing Ed Sheeran music at loud volume. And it wasn't necessarily the fact it was Ed Sheeran, it was the volume that was causing the problem for the neighbour. So when we start looking at sound and how we're going to deal with it, we are looking at trying to break down the ways in which sound is transmitted. Now, primarily when I talk to you and you're talking to somebody in your working environment, sound is transmitted by the vibration of air particles. Obviously, in me talking to you today, it's a little more complicated because the air particle movement is then transmitted into electrical impulses, which is reconverted at your end through your speakers. But in reality, what we're looking at is transmission vibration of air particles. Now, in some aspects then, those air particles may then interact with the structure of the building, cause them to vibrate air within the structure, and then transmit that structure through. In addition to that, we get the structure-borne sound, which is partially caused by the volume of me speaking at the wall and the wall picking up the vibrations, but partially also caused by actual physical contact with the structure, which then vibrates those molecules and causes the transmission through the wall. So that, if you like, is the impact noise. That's the sound of the washing machine bouncing on the floor or banging against the wall or something of that sort. And that, again, that vibration, that movement causes the transmission of the sound through the solid structure. So we end up with impact and structure-borne sound as well as a combination of airborne. So when we're looking at a tactic of how to reduce sound transmission, we have to deal with both of those issues. We have to deal with the airborne sound transmission through air pathways around the structure, but we also have to deal with any impact sound that may cause us an issue as well. So what we're trying to do is to look at the best ways of achieving the reduction of that sound level as we go through structure separating spaces. And the two ways in which we tend to do that are either to provide a high density, high mass construction, which actually has an inert property of resisting vibration and therefore deadens the sound and absorbs that sound as it goes through. Or we provide a discontinuity within the construction so that in order for the sound to transmit, it has to be converted from air vibration to vibration of the structure, back to air vibration in the discontinuity, back to structural vibration, and then back to air vibration again before it gets to the person actually hearing the sound. And in all of those conversions, it loses intensity and we reduce the sound level. So as a result, providing discontinuities in the construction can help us reduce the effect of sound transmission, particularly in terms of impact as well as airborne sound. And then we can build into our construction resilient or absorbent materials. Now, resilient materials are basically those that are designed to reduce the impact that occurs. So they'll compress and then return to their original state once that impact happens, therefore reducing the amount that impact and that vibration is transmitted through the structure. Absorbent materials tend to work on the basis of having numerous air pockets within them where the sound then bounces around the pockets rather than through the material, and what gets transmitted is therefore again greatly reduced. So when it comes to what the building regulations are actually looking at, what we have to look at is what spaces we're actually dealing with. So we all expect nowadays that when we buy a semi-detached or a terraced house, we have a good standard of sound insulation between that house and the adjoining property. And there's an expectation with new build as well, particularly that if we're buying a new flat, we expect a similar level of performance. Now, certainly 40, 50 years ago, that wouldn't necessarily have been the case. People would have understood that in buying a terraced property or a flat, you get a degree of noise from your neighbours. But current purchasers and society today is less tolerant of those sorts of aspects. And as a result, they expect a higher standard of performance. And obviously we need to separate as well noise that's coming from other uses in the building. So if we have a flat over the top of a shop or an office or commercial use, we need to provide a degree of sound insulation in that situation as well. So we have to look at how these things play out, how we're separating the spaces and what standard of performance we're looking for in those instances. It's also worth mentioning at this point that obviously the building regulations themselves set some minimum standards in terms of sound insulation and performance, and it's unfortunately the case, I suppose, that the regime we have, people aim to hit the minimum standard rather than perhaps designing for something that might be a little bit better than that or provide a greater degree of sound insulation. From a positive point of view, we do have a regime where it is perfectly possible to test the finished construction of a property before occupation to ensure that we actually get the correct level of sound insulation. And as a regime for achieving compliance and actually demonstrating that, that's a very positive move. We do have alongside that other methods of specifying a construction and certifying that's what's been used rather than providing a testing regime. But the ability to be able to test to see if the construction is actually performing in the way it was designed is a fundamental principle and something that in terms of sound insulation we have an advantage compared with maybe other parts of the structure where it's not as easy to do post-completion testing. So what are we actually looking for? Well, the standard we look for will vary depending on whether we're looking at a new build or a change of use. And again, perhaps early on in the design stage, those of us doing the design, doing the redevelopment, perhaps dealing with building control, need to be looking to educate the end user in understanding that the sort of performance they're going to get in a converted property as opposed to a brand new property is going to be different. It's never going to be possible to achieve the same standard of construction in an existing building where we are changing the use as we might get in a brand new building where we can deal with everything from scratch and get all of the construction, all of the specification, all of the detailing absolutely right. So we have some values that we're trying to achieve in terms of airborne sound insulation and impact sound insulation. And you'll see from the table that we are really only concentrating the impact sound on the floors and the stairs to a large extent. So really what we're looking at is the sound of somebody walking in the flat above or the room above us. So we have some standards we're trying to achieve. This is what we can then test to and see whether we've managed to achieve that or not. You'll notice that airborne sound is quoted in terms of minimum values, whereas impact sound is quoted in terms of maximum, and that's purely because of the way in which it's made. Minimum values of airborne sound because that's how much we're looking to reduce the sound transmission through the wall. Maximum values in terms of impact sound because that's about how much can be transmitted through. Okay, so we have some standards there that we are trying to achieve. Just before I start looking at how some of the constructions we might use, I'm just going to pick up a couple of early questions that have come in. The first one, in change of use office to flats, it's often difficult to obtain a test. Any suggestions? Well, realistically, the regime in terms of building regulations has two options in terms of demonstrating compliance for sound insulation. Either we look at a sound test result in situ on completion, or we construct using a accredited robust detail, which isn't necessarily going to be always appropriate for a change of use type situation. So we do have to look at a testing regime. There will be practical issues in terms of testing, so whether we can actually get it to work, whether we can physically put it in, but as far as possible, that's the best way to demonstrate compliance. Graham's asked the question, are insulation levels in hotel environments the same as domestic? Well, no, the values I've just put on the screen there are in relation to dwellings. What you would expect in hotels is a slightly different scenario, but not totally different. Hotels, because they're a short-term occupancy, will have a different sort of status. They're not necessarily dwellings as such, although they are residential accommodation. So we are looking at a standard, but the standard may well vary slightly. What you tend to actually find in the hotel environment is a lot of the clients look for a higher standard of insulation because they actually mark it. Far be it for me to recommend any particular chain of hotels, but some of the budget end of the hotels, the sort of Premier Inns, Holiday Inns, those sorts of places, will guarantee you a good night's sleep and a good standard of noise protection from next door. So they look to put in a higher standard than perhaps we would expect to see. Another quick question, am I going to cover other building types, sound testing, offices and hospitals? That's not part of today's presentation, to be honest. The main reason for that being that I've tried to focus as far as possible on building regulation compliance. Excuse me. And although there are standards for sound for hospitals, for offices and for other buildings, particularly things like schools, they're not part of the minimum standard that's specified in building regulations. A lot of it comes down to health and safety in the workplace and what's suitable levels. But the same sort of principles apply in terms of how we provide insulation and how we achieve sound reduction. All right, excuse me. Okay, so moving on to look at some of the constructions. As I said earlier on, what we tend to try and achieve is either dense construction or discontinuity, breaks in the construction to prevent the sound being transmitted. So the four basic types of construction we might use might be something like just dense masonry, and quite often if we're doing that, you'll lay the blockwork flat. The problem with that, of course, is that you do end up with a continuous joint all the way through the wall in terms of the perps and the bed joints. So you have to make sure those are absolutely filled correctly. We can move over to cavity construction. which in itself is providing a discontinuity. And I suppose at this point I ought to also highlight that the constructions that we specify and are quoted in building regulations in terms of sound insulation might achieve sound insulation but might not meet all other new parts of the building regulations. So things like thermal performance, excuse me, particularly where we're looking at party walls and thermal losses through the party wall. Increasingly though, we're using dry lined panel type solutions where we provide that discontinuity together with a degree of sound insulating material to absorb the airborne sound and to reduce the possibility of structure-borne sound being transmitted through the building. Next slide. Right. So what do we have to pay attention to when we're looking at wall construction? Well, we have to make sure that we're using the right weight and density of construction. The approved doctrine of evidence to the building regulations gives some examples of how to achieve compliance, but clearly when we're looking at a massive construction to absorb and resist sound transmission, we have to make sure we've got the right specification of blockwork, etc. As I've said, we have to ensure that all of our joints are correctly filled, so it has to be a much more attention to detail. Seal the surface of the masonry to prevent the sound getting into the air spaces, and then simple things like the detailing, making sure that if we have to chase in services and sockets, that we do so in a way that doesn't compromise the overall effectiveness of the blockwork, and certainly so that on adjacent sides of the party wall we haven't got sockets and chases back to back, so that we've got the potential that issues are following through. The other thing that's important, if we're using a cavity wall construction, we need to make sure that we've got the right width of wall and that we haven't got any mortar snots or anything that have gone down the cavity. We've got the right standard of wall ties, and quite often with that then a less rigid polypropylene type tie might perform better in terms of sound than something that's a bit more solid. And again, looking at how we ensure that we've got the mortar joints filled, but also make sure that we don't have any major structural elements of the building that actually bypass the cavity and link one side to the other. And then if we're looking at a framed wall solution, it's making sure we've got the right insulation, that it's in the right place, that the boarding lining has staggered joints so we don't end up with a pathway through, that we've got a decent discontinuity in a gap, and particularly where we're looking at a panelled finish, that we seal effectively around the sockets and the services so that we make sure that we maintain that integrity. Right, I'm going to pick up another couple of questions that have come through. With the new London plan requirements of 2.5 metre internal height to 2/3 proposed flat when converting, is there a compressed detailing that can be used then to meet the requirements? So this is basically where we've got a requirement for 2.5 internal height, because that's slightly more than we would expect. So with some of these wall constructions, you get a bit more of a vibration effect on tall panel of walling. I'm not aware of a particular detail. I'm not 100% sure that 2.5 is going to cause us too much of an excessive problem. The other thing I would say with that is, although the London plan is suggesting 2.5, there are moves afoot at the moment to make the national space standard, which was introduced about 18 months ago, apply throughout, whether it's London or not. And the national space standard only requires 2.3 metre headroom, and certainly the last time I was talking to somebody, there was a suggestion that as a standard eventually may find its way back into building regulations where it used to be up until the mid-1980s, when we used to control headrooms to the property. But it is something to consider. The taller the panel, the more potential vibration you end up with, and the potential sound transition you're going to get. Another question, as builders often build to the bare minimum requirements, are there any plans to raise the minimum requirements for sound insulation in the building regulations? Well, there's the question as of today: are there any plans to do anything with the building regulations? Following the announcement yesterday in the news, we're probably going to drop into what the government call PERDA, which means government departments can't talk to you about anything policy-wise until after the election. Certainly at the last time I was speaking to somebody from DCLG, there were no major plans to change any of the requirements in building regulations, particularly in relation to sound insulation. The current level of thinking is that the levels that are required in the regulations at present, if people achieve those levels, are sufficient to prevent any form of noise nuisance, and therefore there's no anticipation that they will be changed. I would say actually sound insulation levels are probably one of the things that have stayed fairly constant for a considerable period of time now within building regulations and haven't necessarily changed in the last decade or two, really. Okay. So, moving on. So moving away from walls and looking now at floor construction. Again, what we're trying to do with floor construction is consider some of the issues around sound transmission. But obviously one of the aspects we have to take into consideration is the impact, the effect of somebody walking across the surface, electrical equipment that may be sat on the surface like washing machines, tumble dryers and the like, and also those big hefty speakers serving the sound system that might be sat upon the floor. So in addition to having a dense construction to absorb some of that, what we actually try to build into most of our floor constructions are some resilience or soft covering or absorbent layers to take the initial impact transmission away, and then as far as possible to build in density and or discontinuity to stop the sound transmission actually moving through. So there's three examples of how to put together a floor construction there. So a fairly dense concrete base with a soft covering, with the ceiling below, with particular attention there to the fixing and the joining of the ceiling to the concrete base to prevent that direct sound transmission. A floating floor type layer, again with a concrete deck, but a resilient layer in there to take away that impact and reduce that effect. And then the third one, the one at the bottom that can be used for new but quite often is used in the conversion sector as well, is where we've got a floating layer of floor on a resilience sitting on the joist, and then a discontinuity between that and the ceiling joist down below with a further layer of absorbent insulation material in between the joists to prevent the sound transmitting all the way through the construction. Again, what we have to make sure of there is there's no point in fixing a resilient layer on the upper surface of the floor or under the floor boarding if we're then going to fix all the way through. So where we have a floating floor on a resilient layer, we can't then screw that floor through to the substructure to stop it moving around, because that will compromise the resilience. When we're looking at this, as with anything, it's important to have the right material with the right characteristics performing as per the specification. And a lot of manufacturers will have tested their products and have test certificates to show a construction that should achieve the adequate sound insulation we're looking for. When it comes to the ceiling down below, again, stagger the joints so that we don't get those direct air paths through. And a lot of sound insulation and the success in getting sound insulation right is actually in the detailing. So when it comes to the joints and the details, things like floating floors, it's no good if they are then in direct contact with the wall or trapped by the skirting board, because that stops that floating effect, and therefore we end up with direct sound transmission through that point. So a lot of our work with sound insulation and getting it right is the attention to the detailing and the jointing rather than the overall construction that covers the majority of the floor or the wall. I mentioned at the beginning that we're not only talking about sound separation between dwellings, but also within the dwelling. Now, this, I suppose, is, although Part E hasn't changed the sound insulation for quite some while, this is the more modern part of the requirement, and certainly something that originally where sound insulation was considered wasn't really one of the major concerns. And this is about sound insulation within a dwelling. And there is still a school of thought that, to be honest, sound insulation within a dwelling is the responsibility of the management, or in most residential situations, the parents. And if the kids are too noisy in the bedroom, then it should be addressed in other ways than trying to deal with social issues by designing in features within the building. The other problem with dealing with sound insulation within the dwelling is if you're trying to separate noise from one room to another, but you have to put a door in the wall in that room, then it doesn't really matter what you do to achieve the sound insulation to the wall, you're not going to achieve a decent standard of protection because of the fact you've got a doorway there. So actually, when it comes to achieving standards and particularly testing regimes, you wouldn't test that situation with the door in it because it's not going to achieve the sound insulation through the actual door opening itself. So within the dwelling, we're looking to make sure that the bedroom is protected from noise from things like kitchens below, from bathrooms adjacent to it, and that we don't get sound transmission between things like bathrooms and lounge spaces as well. So there is a standard of requirement in terms of what we're looking at, in terms of walls and floors for airborne sound reduction. As I said, it doesn't apply when we've got a door in that wall, and it doesn't apply to the wall that separates the ensuite from the associated bedroom that goes with it. And if you're in an existing building and it's a change of use, then again, you won't look at addressing that as far as the building regulations are concerned within the dwelling itself. So it's a lesser standard. And if you bear in mind the standards we were looking at in terms of reduction before were around the lines for walls and floors of 45 decibels for new build, separating buildings. 40, because of this logarithmic effect, is a much reduced standard of sound separation that we're looking for. What we do have to consider, and what a lot of attention is paid to when we're looking at sound insulation, is the issue of flanking sound transmission. And this is basically where we design a perfectly adequate element of structure to resist the sound insulation, but we have numerous pathways for the sound to bypass that protection. So if you look at the plan section of this drawing particularly, we can have a perfectly effective party wall or a wall between rooms that resists the big red arrow of the direct sound transmission through it. But all of the dotted lines with the little orange arrows are potential pathways for sound to enter the structure and bypass that main bit of construction and make their way through. And so we have to make sure that our junctions of our walls with our external walls, our cavities, sealing the cavities, all of that prevents the sound bypassing the main construction and causing this flanking sound transmission effect. Now again, some of that can be achieved with dense construction. Some of it is actually achieved with discontinuity in the construction. So again, one of the ways traditionally to have dealt with flanking sound transmission around the party wall is actually to have windows and openings reasonably close to the party wall to provide that discontinuity path for the sound as it goes through. But clearly this is where we have to pay a lot of attention. We can get the specification of the wall right, we can get the specification of the floor right, but we have to look at this ability of sound to go round, because if there is a pathway for the sound to be transmitted, then it will get transmitted in that way. Okay, right. So a lot of what we look at nowadays does fall down to completion testing in terms of sound insulation. Where we are told that failures are occurring at the moment relate to poor choice in design in the first instance, but that tends to be the lesser of the reasons for a failure. Workmanship is quite often blamed in terms of how these components are put together, and some of that is due to a lack of understanding of the person actually constructing the detail as to what it's trying to achieve. We do still have an awful lot of problems in the construction sector with the specified materials, which perhaps achieve the density or the resilience we were looking for, being substituted for something similar but not quite the same, not quite tested in the same way, that in effect isn't going to give us the same solution. And then, as I said, the biggest problem with completion testing is really showing up that it's the jointing details. It's that attention to detail to get it, to make sure it complies. And that is really an education process in terms of the person putting the detail together and the level of site supervision that's there to achieve that. But if we do use completion testing to check the performance, then we at least have the opportunity to go back and put things right if we haven't got it necessarily correct. I did mention earlier on the option to that, and the option is that we do sound testing unless we have a new build which has then embodied within the design a robust detail. A robust detail is limited, or an approved body that can give a certified detail that will achieve compliance, that is then checked on site, site control to certify that's actually how it's being constructed. And if we can get that paperwork trail to say that we've had an approved detail that's been constructed correctly, then that can be accepted as achieving compliance without necessarily having a sound test. But it does rely on the correct installation of the material, the correct materials, the correct jointing, and all of that attention and detail, and a level of site supervision. But that obviously is quite a frequently used alternative to the process of doing completion testing on all properties. Right, so I'm going to try and drop back and pick up a couple of questions now, just a couple of other things that seem to have come in. Modern open plan layouts of two-storey dwellings and flats makes much of the internal sound insulation redundant. Yes, totally agree. When you're looking at levels of sound insulation within the dwelling, so between the bedroom, the living room, between the bedroom and the bathroom or whatever, if you have an open plan layout, then clearly you're not going to have that level of sound insulation. And I suppose really what we're dealing with there is the expectation of the end user and the purchaser. If somebody buys a flat or a house and it's divided up into individual rooms, they expect a standard of sound separation. If somebody buys an open plan unit, they would expect that it's not going to have that same degree of sound insulation. So in reality, yes, you know, it's down to what the end user is expecting. So if somebody chooses to put the bath in the middle of the bedroom with no surrounding wall, then you're going to expect to hear the bath filling. But it's an expectation level and what people can reasonably expect of their premises. Okay, and can you confirm that the use of robust details is inappropriate for dwellings formed by a change of use? It does depend on the bit of the construction you're looking at. Generally, robust details are there for new build, and that is because you have to construct the whole element as per the robust detail. And obviously, with a change of use of a property, there is an element that you are always going to have an existing construction you're working with. Now, people do argue that if I'm putting up a brand new wall where there wasn't a wall before in a converted change of use property, can I use the robust detail for the construction of that wall? The only issue with that is, of course, how is that wall then supported? What it's sat on? What is the floor construction? Because that won't necessarily deal with some of the flanking sound issues we're dealing with. So in general terms, unless you're looking at a totally new build envelope within part of the project, then you are looking at having to go to a testing type regime rather than maybe having an acceptable robust detail. Somebody's just asking, am I going to cover reverberation in common areas? It is another topic. It isn't something that was down for today's agenda, so sorry about that. What I would say is if you have any particular case studies, any particular problems with reverberation, then we can take that on board and look at it as coming forward as another subject. I would say that the only issue I've had with reverberation in common areas of things like blocks of flats is some practical stuff. That blocks of flats, the common areas, are covered by the Regulatory Reform Order Fire Safety, and therefore require a fire risk assessment. And I have come across a couple of instances where landlords have chosen to carpet staircases and common hallways in smaller blocks of flats to deal with some of the reverberation issues in terms of noise and reverberation, because you obviously, as far as other regulations concerned, soft coverings on the floors are allowed, whereas coverings to the walls and ceiling are a little bit more problematical in terms of fire spread. But I have seen some fire services look very closely at risk assessments and the quality of surfaces, particularly carpets that have been used in those common areas, as to whether or not they would contribute to a fire in a fire scenario. So it is a difficult subject to look at, and maybe perhaps, particularly if some of you can give me some good case studies, it's something we can bring forward for a future webinar. Okay, and I think there's just a comment there talking about sound testing for change of use, which I think we've sort of covered on as well. Katie, have you picked up on any other questions?
Hi. No, as far as I can see, everything that's come through has been covered off. So really, if anybody's got any further questions that they want to submit to us, now is the chance to quickly type those in. Oh, and there you go.
Right.
Get those over.
I was going to say there was just one thing I was going to pick up on. I think one of the delegates today, Colin, has raised a hand on the system. Unfortunately, we haven't got the ability to unmute as we go through today. So Colin, if you did have a question, if you want to type it into the question box, we'll try and pick it up now, or alternatively we'll pick it up later on. Couple of other little bits and pieces. What about open snug rooms and other open areas in residential homes, which has a problem to dwelling units? Will advise was requested. So that, I think this is again sort of common areas and stuff, which I think from the comments that are coming through, to me suggests perhaps there is scope for more work here. So whether we look at another webinar or we look at some other way of getting more information out about this, it's clearly something that perhaps people expect to see as a way of taking forward and perhaps looking for a little bit more information. And just a quickie there at the bottom about testing and declarations and when's it acceptable. Ultimately, if we're looking at any form of construction that's creating a residential unit and we have a test result at the end, and the test result demonstrates that we meet the performance standard of building regulations, then as long as the testing is done by a suitably competent person with calibrated equipment that's been calibrated by a UCAS approved body, then in reality it's acceptable to take on board that test certificate and accept that as demonstration of compliance with the regulations. Okay, any suggestions for further reading? Well, there's a wealth of information out there on this subject. So obviously the baseline start is to look at the approved document E to the building regulations. There's an awful lot of additional material that goes over and above that in the material that's provided by the warranty providers for dwellings, and also in some of the technical handbooks provided by organisations like LABC for local authorities and HBC for their inspectors. And then it's just, again, generally anything that's out there in the technical press. Quite often sound insulation is a hot topic in professional journals, and there are a number of other major books out there. What I might try and do is put together a bit of a reference that we can attach to our website for frequently asked questions to sort of point you in the other directions. Okay. Otherwise, I think we've pretty much covered off everything that's there. So Katie, if you're okay, I'm going to hand back to you just to wrap up.
Yeah, that's absolutely fine. Thank you, Kevin. And just to respond to Stephen's comment about the slides being available after today's presentation, what we'll do is we'll be uploading this presentation to YouTube, so you can get slides and audio. So that will be available hopefully within about the next hour. I'd imagine I'll be able to get that online. So just check out our YouTube channel for in effect a rerun of today's event. So again, thank you, Kevin, for your time, for your expertise again this morning. I'm sure everybody's found that very useful. So moving forward, where are we going next? Well, our next webinar will be on Wednesday the 17th of May, and we're going to be looking at cavity walls. So all elements regarding cavity walls, so insulation, damp-proofing, etc. So we'll be looking at that. We'll then move forward into June, looking at safety outdoor events. So for anybody who's involved in perhaps events in your area, just making sure that they're all compliant and all the safety elements are all covered off. And then into July, we're looking at designing to minimise the risk and impact of arson. So a fire webinar for you there, looking at arson. So that's what we've got for the next few months. We're now working frantically to put together a programme also for the autumn, so this should be published within, again, the next couple of months. So if there's any subjects or topics that you'd think would be useful for us to cover, please do let us know, and we'll see if we can draw those into our programme. So thank you very much, thank you for joining us, and we will see you hopefully online next month. Thank you, goodbye.